Here, we're on page 40, and we're starting up the first chapter, and this one's entitled Open Sentences and Solution Sets. So we're going to start off the first lesson in our second chapter of math talking about sentences. Now, it's not converting word phrases to algebraic phrases, but we're going to be talking about this main concept right here, equations. There are two types of equations we deal with in algebra, in math really. And the first one you wrote down is open sentences. So you need to get this down because I'm going to ask you, is this, and you're going to have some expression or equation, is this an open sentence or is it closed, which is going to be the second one. And you'll be able to answer based on hopefully what we have in the notes. Open sentences are equations that contain variables. Okay, they contain variables, such as this one right here. This is an open sentence. Does it have a variable? Yes. Is it truly an equation, though?
Yeah, because it's an equal sign.
It has an equal sign. Automatically, it's an equation. But, opposed to the closed sentences, this equation is neither true nor false. To be able to say that this is true and false, you don't have enough info to make that decision. We will get into that. But an open sentence by itself is neither true nor false. So the second type would be a closed sentence. That contains no variables. So open have variables, closed have no variables. So there's a big difference there. But closed sentences are either true or false. So those can be true just the way they're written, or false just the way they're written. So if you write that down, if you haven't already. And I'm looking at, whoa, doesn't this look a lot like the one I wrote in the previous screen? What's the big difference?
There's a 4.
There's a 4 instead of the variable. So if you have the value for a variable, you can now determine whether it's true or false. And you do it just the way we did it last chapter. Yes, sir?
You just pre-write all your numbers.
Yes. Yeah, it's. I found it with 7th grade. It's more efficient, and so it helps me to go quicker because you guys are quicker than I am in writing, and then you get more time for your homework, which is nice. Yes, ma'am.
Sure, when we go to high school, will we be in the honors geometry?
You could go into honors geometry, yeah, or you could do honors algebra 1 again. That's usually the two options, or college prep algebra 1. So really 3 different options, 2 main options. 1 is going to be for most of you.
What about algebra 2?
You could technically do algebra 2, but you also have to take geometry. Either you take it in the summer or at the same time as algebra 2. And I'm not going to recommend that for a lot. Some maybe, if you want. Okay, anyway, looking at this, I need to determine whether this is true or false. So this equal sign is saying this is equal to that. And we need to verify if that's a true statement or not. So 14 stays the same. And then what do you think I have to do here, or what do I have to consider to make this simpler so that I can compare the two sides? Yeah, I use what's that process or that? I heard it, somebody said it, order operation. So what's going on between 1/2 and 7? And then 4? And then what property says you can do it in any order? Commutative. Okay, so I'm going to do 1/2 times 4. And what's that? 2. And then times 7 still gives me 14. Is this true?
Yeah.
So you write the word true. This is true. So you're going to get problems like that where we give you a value for the variable and you have to tell me, is it true or false? And so we just verified that to be true. Yes, sir?
Does it matter what order we do?
No, because of the commutative property. You could have done 1/2 times 7, which is 3.5 or 3.5 times 4 is going to get you 14. So either way, I just like multiplying a half by an even number and then times that odd.
I'm so really confused on why you put the 4 there.
Oh no, the problem just puts it in there for you. You don't decide whether to put 4 or not. We put it in there for you.
So you don't have to use it?
This 4? No, we do have to. We did it here. 1/2 times 4 is 2. And then 2 times 7 is 14. Okay. All right, next one. So how many of you can distinguish the difference between a closed and open sentence? A closed sentence has what? No variables. And an open sentence has variables. Okay? A closed sentence, can it be true or false?
Yes.
Okay? It could be, closed sentence, can it be true or false? Yes. Open sentence, can it be true or false? No. So you need to be able to distinguish that. Let's look at the next type. All right. This is a type of problem, example number 1, that you're going to be doing. They give you an equation. And I know it's an equation because it has an equal sign. And they also give you what that variable is worth. And I'm glad we get to go over these problems because it's kind of like what you did chapter 1. And now we're going to do this a lot more and hopefully you'll be ready. Do you guys remember instead of the variable? So I'm trying to determine whether this is true or false. Is this an open or a closed sentence? Open. Why is it open? Yes, ma'am? As a variable in it, boom, it's open. And it's a sentence because it's an equation. So you can think of it that way as well. Yes, ma'am?
Will be a closed sentence once you have the numbers instead of the variables.
Yeah, it'd just be numbers, and you would deal with those numbers. Yep.
So if this was like, is this a closed sentence or open? Would you say this is an open sentence?
This right here is an open sentence. Yep. All right, what did I do instead of what did I place or what did I substitute the variable with? Yeah, parentheses. And I'm telling you right now, as I look through your homework, the signs are going to be mixed up if we're not being careful with those variables and what they actually mean. So what does m equal? 3. So you just put 3 in for both spots right there. All right, order of operations says to do what in this problem? Add. So I'm going to add 3 plus 7, I get 10. And 10 times 5? 50. So does this look familiar? I hope you're like, yes. We saw it. When's the last time you saw this kind of problem? Yesterday afternoon, so not even 24 hours ago. All right, what do you do on this right side? Yeah, you do 15 plus 7, and you get 22. Is this true or false? So you write false. So in this open sentence, if m equals 3, then you have a false open sentence. Does that make sense? Okay, so you'll be doing some of that on your own. Yes, sir. Okay. You guys get how to do this? You get how we're applying order of operations. And then how we're applying sentences and open, closed, variables, no variables, all that. Yep.
And the description of it, since you said this is an open sentence, it says neither true nor false.
Yeah, so... Yeah, so here, great question actually. This is an open sentence, right? Once I put that variable, once I put 3 for the variable, it becomes now a... Very good. Actually, Chelsea, I'm glad you brought that up. Okay, guys, up here, what they gave me was what kind of sentence? Open. This is open. But when I put 3 in for the variable, what did it now become? Closed. So now I can determine true or false. That's a great point. Thank you for bringing that up. Okay, next one I want you guys to do on your own. Just go ahead and find out if this open sentence would be true or false when I put in k equals negative 2. And if you're not careful, you're going to get something that's pretty close, but unfortunately is not the correct answer. And by the way, you have a 50-50 chance on these, but that's not going to help you in the long run because I'm going to look at what did you get, does it match up your true and false statement. Did you guys get true?
Yes.
Okay. You notice here, when I substituted negative 2 for k, that's negative 2 squared. What's negative 2 times negative 2? Positive 4. So that's how I get a positive. If you got a negative, you get negative 12. Negative 12 plus 18 is 6. 6 does not equal 30. You would have put false, but that would be false. You get what I'm saying? If you put false, it's false. Wait, no. If you put false, it's not true. If you put false, it can't be true. It's false. I'm confused. Okay. Next one, next type of problem you'll be doing. Go ahead and write this problem down. I want you to write this down. Write this down because you'll have it in your notes. So what we're going to be doing is also looking at what we call sets of numbers. We're going to be looking at what we call a replacement set, or another name for that is domain set. So they're going to say the replacement set is blah, or they could say the domain set is blah. And in this example, you have this replacement set. Do you notice the braces I'm using? And then they wrote 3 numbers for me. You can have 3 numbers, you can have 4 numbers, you can have an infinite number of numbers. But that's later on, so don't worry too much about that yet. Yes, ma'am?
So is the thing in the brackets the domain set?
This is the domain set right here, in the braces right here. And then find the solution set for this equation. Okay, there are 2 types of sets I'm talking about in this problem. A replacement set and a solution set. So there are 2 sets. The replacement set is what they give to you. They will give you, here's the replacement set. And what you're supposed to do is look at this type of sentence, which is what type of sentence?
Open.
Open, because it has a variable. And you're going to replace this equation with all 3 of these. You're going to do 3 separate problems, which really just one problem, but 3 problems. And then your solution set is going to tell me which one of those elements make this a true statement. Okay, and I'll show you. We'll work this problem out 3 times. Yes, ma'am.
Isn't this like the chart thing that we did last year?
Yeah, it is. We did this when we were trying to do like graphing a lot. So yeah, you've done this before. Everyone good with this problem? Okay, here's my next screen. It took me a while to write. Yes, ma'am. I wrote this problem down 3 times.
Well, this equation could often be false.
They can all be false. Yeah, we're going to actually go through one that's the case. What happens?
Is this not one that happens?
This is not one. Yeah, this one has a solution set. Yeah, you can have all of them be true, a few of them be true, one of them be true, or none of them be true. So there's a huge variety. So I'll show you what you do. Yeah, if you can write all, it's 3 problems. We're going to do this 3 times. 3 times! Yeah, 3 times. And they're not that bad after the 3rd time. You're pretty good at it. Yes, ma'am.
The last one,
Mhm.
when you said find the solution set for that, can you solve that?
Okay, when you say solve, so when I hear the word solve, I think there's an open sentence, and I don't know what the variable equals. But they gave me what they want it to equal, and you just had to tell me if that's true or false. So here's what I mean. Okay, when they gave me that first expression on this previous page, is this open or closed? Open. And then here, I replace it with the first element, -2. So now it's closed. Then 0, it's closed. 2, closed. And then I have to determine true, false, or true, false. That's same problem. Yep. So I'm just working it out. I need some space. Okay, here, what do I do first? So you see these absolute value signs here? Okay, but what do I have to deal with within the absolute value signs? Exponents. So I get 3 times 4 minus 1 equals 11. Okay, what do I deal with next? 12. So I got here the absolute value of 12 minus 1 equals, what's 12 minus 1? 11. Is this true? So I'll just put true. True. For now, and then I'll show you what you do with your true answers or false answers. All right. Do it again for that one and the other one. Tell me if they're true or false. And I'm going to ask you, what did you get? Like, what equals what on the second and on the third? So, Mr. A, I'm just going to guess false. You may be correct, but what did you get when you worked it out? Because I want to see that. I'm actually going to do this to separate it. True or false? So if you put the absolute value of negative 1 equals 11, or you just put 1 equals 11, it's still false. So that's a false one. And then here, notice anything about this problem? It's exactly the same. Does anyone know why? Because it's different numbers I put in.
Because there's an absolute value.
Okay, there's the absolute value sign. Yeah, a negative 2 squared is the same thing as a 2 squared. So this one's true. Okay, how many of you got these problems worked out? You got these different equations at the end. True, false, true. Okay, my answer, and I think I'm going to have to add another screen. Yep. I'm going to add here. My answer will be this. And you don't have to write this word out, but I'm just emphasizing it. So on that problem we just did, the solution set is negative 2, 2. That's my solution set. That's my answer. No, you don't have to write the word out. You just have to write that. I'm just telling you that's my solution set. So which one of these gave me a true answer? If I put negative 2, true. If I put positive 2, true. So those are part of my solution set. That's my answer. Do you guys get that? Okay. You're going to be doing a lot of that. Well, I think you have like 5 problems like that, and they're not going to make you work out a ton like I will do soon to you. Very, very soon. Yes, sir, Braden?
So, like, someday, like, I know, like, we're not going to do this, I don't think, but, like, couldn't, like, we get one of those problems, like, 3 of those problems, like we just did, and use that to graph it on, like...
Oh, yeah, and we will get it this year. Yeah, we'll do that, but not for long because there's a better way to graph. Okay, how many of you are good on this? Like, you get what you're supposed to be doing? Okay, what I want you guys to do is on page 41, I want you to work out numbers 1 through 5. Now you're like, wait, we got to do 5 problems. Read the instructions. Give me an answer according to those instructions. And these are the 5 problems. So if you're confused, I would be too, unless I read the instructions and then it's like, that's what they want. So what you want to do on those problems is you're going to write if it's open sentence, true sentence, false sentence, or expression. You have 4 options. Oh man, did we even talk about expression? Ooh. Did we talk about sentences?
Yes.
Mm-hmm. Okay, yes ma'am?
Can it only be one?
It can only be one of those, yes. It's got to be one or another. Okay, the first one. I'm just going to help you out here. Open or closed? It's closed, right? There's no variables. So is it true or false? That's when you have to answer if it's true or false. So let's see, what's 2 to the 5th? What's 5 squared? Okay, by the way, guys, you see how they switched the numbers? They're not equal. So this is false. We call it a false sentence. That answer to number 1 is a false sentence. It is a sentence. It is closed, but it's false. That means it's not true. Wow. Did I just define false by saying not true? I did. So that's how you need to know it. Yes, ma'am.
So would you write like picking number 2 to like if it's open or closed, and then you would write?
No, on that one I think they don't give you a closed sentence option because if it's a closed sentence, it's either true or false. So yeah, they don't give you that. But if it's open, can't do anything about that. It's just open. Okay, second one. Is it a sentence?
No.
Why not?
No equal sign.
No equal signs, therefore it's just an expression. Yes? Okay. This? Okay. Is it an equation? No, so it's an expression. It has no equal sign. It can't be, thank you, it can't be an equation, and therefore it's not a sentence at all. It's just an expression.
Why don't they call the sentences equations?
Yeah, and it really has to do with, what makes a sentence a sentence. It has to have a subject and a predicate. Or I think of it subject and a verb. So you have a subject, you have something you're talking about, but there's no action being taken other than they're being multiplied.
Like the closed sentences.
Uh-huh.
Why wouldn't they call that a closed equation?
Oh, I see. Yeah, so this is what I'm saying. The sentence in English is directly related to an equation in math. So you need to know those actually fit together. So English invaded math and vice versa. Man, I don't like when that happens. Okay, it happens a lot. Next one, number 3. Let's go with Laura. Which one is it out of those 4?
3.
Sorry? Yeah, number 3. Yep.
Open.
Open sentence. Why do you say that?
Because you have a variable.
Has a variable. You can't tell me if it's true or false. You can just say it's open. Like it's open for whatever X is going to be. Okay, number 4. Josie. True sentence. Okay, so it's not open, but is it true or false? So did you get 8 plus 6 equals 14? And that's true. So it's a true sentence. Good. True sentence. And lastly, Jake, what is number 5? Open sentence. How is that even possible, Callie? Yep, has a variable. So you can't determine whether it's true or false. And I would say 99.9999% you could say that's open, but there are times where you could say if it's true or false, even with the variable. So I'm not going to give you those. All right, you guys good on open, close, true, false? Okay, I'm going to give you one last problem when you're done with this problem. You can, it's number 9. You can get your homework started, which I'll put up here on the board. Number 9. Using the replacement set, and they give me the replacement set right here. It's -2, -1, 1.2, 2, and 4. Give me the solution set for -b squared plus 11 equals 1.5. So guess how many times I'm going to work this problem out? 5 times. Good counting there? 5 times. What? I only wrote it 3 times. Oh, yeah. I needed some extra space. Okay, I need some volunteers because I'm done working up on the board by myself. I get nervous. Sorry? What do you mean by this long? No, yes, you will have to, but not many. It's not like all of them are this, but you will have some. All right, volunteer? Sorry, who's going to volunteer? And then I'll get the question. All right, 1, 2, 3, 4, 5. 4 and 5, you got to wait till 1 through 3 are done. 1, 2, 3, you can come on up. I have 3 of these little markers that you can use. So go ahead. Number 3, 1 through 3, go ahead and work it out. Don't run into each other physically or mentally, I guess. Thank you. I would do it. Yeah, if you want, work it out on your paper. If you don't, if you want to work it up here, I'm okay. Okay, question, Chelsea.
Oh, I'm just gonna wait and switch this because I just have a question. So like, if it's, see how it's -b squared,
Mm-hmm.
and then there's -2, so like, would you, and then outside of that?
Okay, so this is, I helped you guys out on this. You see I put negative parenthesis squared because it's negative variable squared.
You're doing -2 on the first one over there.
Are you number 1 or number 2?
All 3.
3? Okay, so Josh, you can do this one and you're going to fill it in with the third number, 1.2.
1.2. Okay.
Yeah. And you have that space to work. So yeah, Chelsea here, who's number 1? So Sydney, what are you going to put in for B? -2. So I do it like this. I do -2 squared and the opposite of that. You got to be careful with those signs. And that's why I did it for you. Next.
So is that basically saying positive 3 squared is the opposite?
No, because in this case it will work, but if I put a 3 exponent, then it does switch the sign. So just be careful with that sign because it matters. Yeah?
The micro, why is there a negative there? Because,
Your problem?
yeah.
Oh,
Because when
do you remember this? And this, I'm going to try to drill this into you guys because I want you guys to get it. Ready? Isn't this -b squared? So what's b in Bella's case? -1? -1 squared. You got to think of it that way.
only one. Doesn't make sense because the negative negative
Oh.
times negative.
Do you mind erasing that circle? And then, give me true or false, Josh. Just tell me if it's true or false. Okay, put false. There you go. Yeah, if you want someone else to, I don't mind having someone else. Okay, I need a replacement set for that. Thank you. And then Sydney, you're the first one. I'm gonna go Cole, second one, and you can come up, Cole, and just do it. Bella. So let me explain it while they're working. Okay, do you notice the original problem says negative b squared?
Yeah.
Okay, so it's saying whatever b squared is, it's the opposite of that. Okay, so what's b in your problem that you would have taken? So it's negative 1 squared, but the opposite of that. Whatever negative 1 squared is, the opposite of that. False. Oh, man.
So I'm doing negative 1.
You do negative 1. And then, Josh, you did... Let's see, you did 1.2. 1.2, yeah, 1.2 squared would have been 1.44, and 1.44 plus 11 is still false. Yeah, careful with those decimals. What I do like about our new curriculum, although I kind of was like at first kind of iffy, is that they're going to make you do a lot of decimal and fractional problems because I want you to get more comfortable with those because they're not easy. But it's good to... Oh, false again? What?
Mr. Ray?
Yes.
Wouldn't it be negative 1?
Yeah, right here, Cole, you got the... So this you don't do first. You do negative 1 squared, which is positive 1, and then you get negative 1 right here. It's still false. Yeah, it's still false, but we're thankful for that. All right, 4 and 5. You guys ready for this? Oh, Josh.
You know, in our class,
Wait, Mr. Ray,
There's 2 right there. Say that again, Josh.
there are ways checker answers than
Yeah, not here. I'm sorry. Yep, that's one of the shortcomings. But I do allow, I'm a little bit more flexible toward you talking to each other about it. But that's going to say, okay, don't do this. This is the worst thing you could do. Because you'll get a point on the homework and you'll mess up on the quiz. Hey, what'd you get? Oh, thanks. Okay, got it. And that didn't help you at all. So she had positive 2? Okay. So she got here negative. So what's 2 squared? 4. What's the opposite of 4? Negative 4 plus 11. That's... Oh, what's negative 4 plus 11? 7. Yes, 7. Positive 7. So 7 does not equal 1.5. Yeah, and then 7. Okay. That's a false statement. Uh-oh. How many of our replacement set was true? None. So what do we put for the answer? I think someone asked about. You either put this symbol right here. That means null set. That means there's nothing in the solution set. Or you can put, I mean, this is quite literal. There's nothing in there that belongs. So either one of these is going to be an answer. This means right here, null set. And you actually, some of you, if maybe your parents are like programmers, you say null, they'll know exactly what you're talking about. It means empty. Nothing's in that programming language. Or if someone leaves a field blank, what happens to the program? And this means empty set. Empty set. So that means there's nothing in the solution set. None of those were solutions. Does that happen? It just happened. Okay. All right, your homework then is 2 to 22 even, and then pages 39 and 40. Read the instructions, because some of them are going to be very straightforward. Just write this down, and some are going to be work these out. There are 3 problems where you do it with a few more numbers than normal. Oops. All right, goodbye, Swivel.